All right, good evening, everybody. My name is BAKEL BAKEL, and I'm going to be the instructor. I hope I'm audible. All right. Basically, this is an orientation class. It's more like, you can call it an onboarding. The program is going to run for the next 8 weeks. And the, the main idea behind this particular class is to get us acquainted with the structure we're going to be using, the procedures, the topics we'll cover, and generally everything about the training. Now, there are some general rules that I use when I am teaching. First of all mics should be muted. You can unmute your mic when you have something to say. And there are times you have questions and you can't really talk or you don't want to talk. Just drop it in the chat box. I always look at the chat box from time to time to answer questions. Then there's a raise your hand option here. Feel free to use it, and I think it creates a queue, and I would get to you when I can. And I also recommend you have a note. It could be digital. The idea is I tend to tell stories, I tend to give examples, I tend to say a lot of things when I'm teaching, and you might want to jot down a few things so you don't forget something. Now, that being said, let me just give a brief overview of the main company that is handling this workshop. Now, Aurora Robotics is it's a group of skilled Nigerian robotics engineers. We created this out of the obvious deficits in our country, Nigeria. I mean, there are a couple of companies that are doing pretty well. Terra Industries, to name a few. But we decided that okay, I mean, it's really not enough, and we can do something about it. So why not just do something about it? The idea of the company is, firstly, education. The reason why education comes first is at times education is underrated, but if there are no skilled talent in the first place, if there are no talents, if there are no educated people, we won't be able to have the next three options or anything concerning robotics. So the company, we specialize in education, we specialize in robotic software development, hardware design and prototyping, and full-scale production. But for the time being, it's just education and software. We haven't done much of hardware, neither have we done much of full-scale. It's just it's a young company to start with. Now, there's something I believe in. I believe in networks. I believe that somebody should not be isolated. Yes, you can work on your own, you can work in silence whatsoever. But most of the things most of the achievements that shake the world are things done as groups, in teams. In a team, you tend to achieve more. So together with Aurora Robotics, we decided to start up Interstellar. And Interstellar is more like the network. Anybody, students, professionals, can actually be part of Interstellar, and it covers a wide range of Industry 4.0 or 5.0 skill. Now, if you've not heard of Industry 4.0 or Industry 5.0, we are familiar with the revolutions, the steel revolution, industrial revolution, and things like that. So there is the digital, which is what they call the fourth revolution, that's an Industry 4.0, where we focus more on IoT and internet connected devices and things like that. And then there's Industry 5.0, but that's very new, and it's a concept being introduced by Japan. So I'm just explaining in case this is the first time you are hearing something like that. So skills like these, now you might also ask what kind of skills fall under Industry 5.0 or Industry 4.0. We have digital twin. That's like one of the most predominant skill. And if you don't know what digital twin is, which is likely, think of it as, please please remute your mic. If you have anything to say, just drop it in the chat box. So as I was saying, if this is the first time you're hearing about digital twin, think of it as replicating real life in a simulation. So it's like you have a car in real life, you completely model and replicate both the physics, both the material, the body, every single thing of that car, such that you can predict what happens in simulation and use it in real life. It's a bit complex and a bit confusing for someone who hasn't done it, but like that's a surface explanation that we can work with for now. So in Interstellar, one of the things we look at is training and mentorship. Right now we would also go to a few people that are part of Interstellar that are like under the mentorship. We look at open source projects. Open source projects, we'll also look at them throughout throughout the course of the training. There's particularly one open source project that Interstellar has been involved in. We'll also look at that. And then competitions, internships, and scholarships. These are things that we would look at in the nearest future. In case there's any questions, feel free to drop in the chat box. Now, I'm not actually doing this all alone. So we'd love to look at the team that we are going to, or that is going to carry us throughout this journey. We have Prudence. Prudence is a graduate of electrical electronics from FUPRI. He specializes in industrial robotics, and this is something he has been doing since he graduated from school. He's also part of Enactus FUPRI. For those that are probably hearing Enactus for the first time, um, Enactus is this non-profit body that's do research, and their main goal is student entrepreneurship and sustainability. So he was part of that. He was the IEEE team lead, the students chapter in FUPRI, and has nice stacks, works with Python, embedded systems, and ROS. If you are new to some of these terms, we are going to look at it throughout this training. The next person on is Saka. Saka is a friend of mine. When we actually got him on the training because somebody made a request. Somebody said he would love to see application of agriculture or application of robotics in agriculture. And Saka is someone that actually has a very loaded portfolio in something like that. So he graduated from Lautech in Lagos. He's also the lead for Robotics and AI Innovators Network. Couple of awards. Hack for Livestock is another popular program that is carried out by the Ministry of Agriculture. They try to apply AI to solving livestock problems. That's just the idea. So you can also feel free to Google it in your free time and just broaden your scope. He also has expertise in embedded AI. Now there's AI and there's embedded AI. I'll give a very short example. Say for example, um, your Netflix recommends things for you. Basically, that's AI. But now when you wear an Apple Watch or any smartwatch, and that watch is able to like use your data, your heartbeat, your blood pressure, and like to predict when you're healthy or not. That is embedded AI. So it's AI, yes, but then it's on an embedded system, basically embedded AI. Now we look at he also specializes in real-time systems. Real-time systems are a bit more complicated to explain because then we have to talk about how CPUs work, but we'll cover that in coming weeks. Then digital twins and simulations. Now his passions are agriculture, intelligent robots for agriculture. So along the line, we're going to have him, and he's going to also share his experience on how he applies robotics to agriculture. And now we have Queen Etta. She is one of the best students from Covenant University, computer engineering, and she specializes in autonomous navigation. Generally, her passion is for self-driving cars, right? She's also first runner-up for Shinovation and a lead innovator at RAIN. We have Margaret. Margaret is underwater robotics. Now, basically, I specialize in underwater robotics, so he's also one that specializes in underwater robotics. He's directly under my mentorship at Aurora, and we'll be seeing him from time to time. And then finally, there's me. Also, we have their links in case you want to connect with them. Their LinkedIn is below. I can put it in the chat upon request. Then the slides will be available to you all too. So then there's me. I actually had a lot of things to write, and I just figured out that okay, I'm going to be your tutor for the next 8 weeks. So you would find out more about me as we proceed. Now, why are we doing this exactly? When I started the orientation, I emphasized on something: the obvious deficits in Nigeria, and the fact that there are. I mean, I held a poll one time on LinkedIn, and the poll was only for Nigerians, because like you can set who your target audience are when you do something like that. So even on the survey form that a lot of you guys filled, there is an obvious deficit when it comes to some ideas in robotics, and that's what we actually want to bridge. So this workshop aims to bridge theory to practical. Theory is not useless. Neither is obviously practical is not useless, but the practical exists because there was a theory in the first place. So people who say it's only the practical that matters, not they're not entirely correct, because the practicals are only there because there was a theory. So none of them are useless. Throughout the workshop, we're going to be bridging theory, practical, we'll be layering it, and then we'll see how it all comes out. Now, we also want to build a community. Yes, there are a couple of communities here and there that do AI and robotics in Africa and the rest of them, but how active are they? How active are they? For those of you that have been following me for a while now, we've actually been very active, and we hope that we can continue at this pace and consistency. Now, we also want to prepare students and young engineers for masters, PhD, and career opportunities. This was one of the major things. This is one of the major things I get almost every day. People message me that they probably want their masters plans. How do they go about these things like that? So on weekends, we are going to have sessions for that. Now, that would be completely different from the whole learning robotics kind of thing, but it's still something that you need to know, because at the end of the day, we all do robotics either to further our career or to maybe go into the academic field. So we have to think of that. Now, we also need to showcase that Nigeria and Africa can lead in robotics. As a matter of fact, it's not a new thing. There are Nigerians that are doing very well, very, very well in robotics, and they are doing that on a global stage, while Nigeria itself is not really being recognized that much. Now, we also wish to, I talked about consistency. Consistency is one of the most difficult things to do. To be consistent is very difficult, and there are people that view me as being consistent, view me as, oh, this person is consistent in what he do, but there is a lot of pain that goes into consistency. So we would also talk about things like this. All right, have we done something like this before? Yes, we have done things like this before, and when I say we, I mean me and a couple of teams that I've worked with over time. Now, I have a long history with education and teaching. It's a hobby. For those people that during the course of the application had the opportunity to be on a call with me, we spent a long time talking, and I can just go on and on and on. However, a little history is from my secondary school to my days in university. I have always offered free tutorials. Free tutorials, yes, not paid, because it was more like passion. And then after school, I opened Baviji's Academy, which ran for a couple of months, but it was only popular in my local school, FUPRI, Federal University of Petroleum Resources. And then we did Regalia Extanja, and this workshop actually attracted about 300 participants. Some of them are on this call too. So that was early this year, and it was a very memorable event for us. So yes, we've done things like this before, and we hope this will be better. Now, this is the idea behind the whole workshop. Earlier, I mentioned that we are going to do the theory, but this way, we are going to move into the maths. And when I mean the maths, I don't necessarily mean solving Laplace or actually doing analytical maths. What I mean is, let me give an example so you probably understand what I'm trying to say. We want a car to move on its own, right? We want a car to move on its own from point A to point B. So the idea now is we want that car to move from point A to point B. Now we have to break it down into concepts that we know. Before something can move from point A to point B, it has to know where it is. I think that is logical. Before you can move from your kitchen to your room, you have to identify that you are in the kitchen. Or let's assume you are outside your house and your goal is to move from the kitchen to your room. You have to get to your kitchen first. Regardless of how you view the problem, you need to know where you are to get to where you are going to. So that is intuitive. Now, in order for you to know where you are as a robot, for we human beings, it's easy for us. We have to be familiar with the place, and then we look around and we know where we are. Now, we have to find a way to tell the robot how to do that. And that is what is called localization. With time, I would explain all of these, but I want to give you how we break down things, or how we will break down things in this training. You need to know where you are to move from point A to point B. So the robot needs to know its localization in point A. Now that's a concept, and there's a whole theory behind it. Now we would move from, at least now we've gotten the concept, one of the concepts to know where you are, we've gotten one of it. Now we look at the maths of how to know where you are. And one of the ways we can do that is by moving around and collecting data from the environment, probably a camera, and processing it and comparing it to probably a map that we already have. That whole process now is what I am referring to as like the maths of everything, because that process involves a lot of mathematics, which we will not go into like in depth, but it will be enough for you to understand what is happening under the hood. So now we have the concepts figured out, at least one of the concepts from moving from point A to point B. We have the maths, the underlying idea, and then now we move to the codes. How do we now actually write this code to tell the robot to look around and compare what he's seeing to a map we've already given it? Now that code and the results would be the simulation. So yes, we're not going to actually work on physical hardware, but I would explain something about the issue of hardware and software in the coming slides. Now, after we've done codes and simulation, we then see how it applies. We are going to sit back and watch your robots try to find its way. And this is just like the whole pipeline that we are going to cover. So it's more like, I want to be able to talk to a robot, and then we say, okay, how do we break it down? We break it down into concepts that we can understand as human beings. And then we do the maths of converting these concepts into, like, let's say a robotics domain, right? So we as human beings, we understand it. Human beings are robots, very similar people or very similar entities. So we as humans, if we can understand the problem, we somehow convert it into a robotics domain. And from there, we can solve or write codes for it. That's the whole idea. So is this a full coverage of robotics? No, no. But when you're done, you would know that, okay, yeah, you actually got a lot of knowledge from whatever it is we are going to do for the next 8 weeks. Now, Bruno Siciliano is he's the best robotics engineer in Italy and one of the best in Europe. And he has been doing robotics for 45 years. And I remember one of his lectures in Prague, which is in Czech Republic, where he said even after doing robotics for like over 45 years, there are things that surpasses and surprises him. And he said this on a lecture when he was talking about reinforcement learning, application of reinforcement learning to robotics. So if reinforcement learning again is a new thing to you, we would still get into things like that. I'm just trying to pass the whole idea we're working with. Okay. Are we going to learn how to make digital twins in this cohort? I heard me. Okay. So what I said about digital twin, that's when I was talking about industry 4.0 skills, digital twin. And if you want me to reiterate, creating a digital twin is like creating a complete simulation of a physical object on your computer such that you can carry out operations on that object as though you were doing it on the actual object. That's digital twin. Are we going to do that in this cohort? No. No, we're not doing that in this cohort. But we're doing simulation. Do not confuse digital twin with simulation. Digital twin is a type of simulation. Yes, I agree. But digital twin there's a lot more to digital twinning than just running simulations. In in Okay, yeah, you understand. Yeah, it's being recorded, just to confirm. Yeah, it's being recorded. Are we going to work with hardware or simulation only? Okay, so I made a okay, I'm going to answer that question with a comment slide, but I'll keep that for you. Can we get the slides? Yes, you would get the slides. You will get all the slides. Don't worry about that. Oh yeah, sure, you're welcome. All right, so I stopped at Bruno Siciliano. Yeah, feel free to Google Bruno Siciliano. He's pretty nice stuff. I worked with him briefly, and there were days I never understood a word he said. All right, program structure. Now this is the way I learn. I must confess, I'm not the kind of person that enjoys sitting in classes for too long. Neither do I enjoy going to class for like very long period of time. So that's why I have 2 classes per week. Um, I feel you don't learn by listening, or you just know what to. I think there's this engineering joke that says in engineering, you don't come to class to learn, you come to class to see what you need to learn. Yes, and that is because when you sit in the class, you are basically just assimilating and saying things, but actual understanding comes from doing it. So this is the idea. 2 classes per week, leaving us 5 days free. Just a moment. All right. 2 classes per week, leaving us 5 days free. There's going to be an assignment each week. So that 5 days, we're going to have a group chat. Yeah. On that group chat, I'm going to be there. All the facilitators will be there. Those 5 days that we do not have class is for you guys to actually partake in some practice. So you try and do the assignments, you try and do different things. Also, there is a problem I noticed. Say for example, GitHub and GitHub. There is somebody that is an expert in Git and GitHub on this training, and I won't really say I am an expert because For you to say you're an expert, you probably know how to do pipelines and a lot more complicated things with Git. There are things they call Git operations and like that. But there are also a lot of people that have never used it, because I sent out that form that you guys filled. There's people that have never used it at all. Now, I don't need you to be an expert with Git. I need you to be somewhere in the middle. At least you know how to upload, submit your assignments with Git. Now, in a case like that, I cannot dedicate a whole class to be teaching Git, because Git is not really robotics. Git is what anybody that codes should know. It's just version control. So instead of wasting time teaching things that are not robotics, the 5 days free that we do not have official classes, we can, organize something on the side. I can send their easy to understand YouTube tutorials on that, and then I just offer guidance and things like that. So that's the idea. Now we have one capstone project, and this is going to be done in groups. Reason is because I want to teach a lot of people the art of open source. Why did I why did I why am I so bent on open source? Now, for those of you that do not know, there is what is called Google Summer of Code. Now, Google Summer of Code is like, it's GSOC for short. It's like Google saying, this summer lasts for like 3 months. You are going to be an intern with a company, that's a software company, but we are going to pay you for being an intern there. So the company doesn't necessarily pay you, but Google pays you, right? Good. So the way the application works is, you apply, you reach out to the company, they tell you how to apply, you apply to the company, you also submit a proposal to Google. So it's like a two-way thing. Now, early this year, for those of you that know Open Source Foundation, those are like the company that maintains ROS and ROS 2. They have a project. They had like a long list of projects where you can apply for with Google Summer of Code, right? So the one I was applying for, right, you can see how much you'll be paid. There was this like chart where you look at your location, you look at the project. If the project was medium or like hard, like difficulty, and then they pay you like that. So I applied. My project was medium, and my location is Spain. So I was supposed to get 4,000 euros for 3 months. And like, that's a lot of money. So many people do a lot of things with that money. I reached out to open source, open robotics. Hold on, let me just get the let me get that. Mm, yeah, open robotics, open source robotics foundation. Good. So I think they changed their name to open robotics. That's why it's get mixed up in my head at times. So I applied, I reached out to them, I applied. We had series of, first you do the proposal, you do some challenge, you do an interview and all of that. So I was accepted into open open robotics, let's call it open robotics. So I was accepted into open robotics to work on the project. So was to add a contribution to ROS 2. I was to port a simulator from ROS 1 to ROS 2. So I got accepted, but Google, the application to Google was not successful, because both of them have to accept you. The company and Google have to accept you. I was rejected from Google on the count that I did not have any open source contribution. And when I mean open source contribution, there are people that they have free time, or not necessarily free time. You see a project that needs some fix on GitHub, and you just like contribute to it. You join their Discord, like coding without being paid. Yeah. So that's why I'm like, okay, yeah, you need to have like an open source contribution. You don't know when you need it. I needed one, and I didn't have one. So I hope somebody got a thing or two from that. So yeah, this is the structure we are going to be working with. Now, all slides, codes, materials, everything will be shared. Now, feel free to use it. Feel free to share it. When I mean share, it mustn't be within yourself. You can send it to whoever you want to send it to. I'm not bothered. But do not modify. It's intellectual property, and you know, it's basically law. I think you guys know about licenses and things like that, yeah. And then we have this meme. Okay. Yes, GitHub is compulsory. I had to include this because so many people were like, oh, why can't we just send you the code? I remember being on a project with one of my friends. He is a naval architect. Well, I'm a naval architect by profession. No, that's complicated because I'm a robotics engineer by profession. Either ways, I'm a naval architect somehow. So we're working on this project and it had some codes in it. And I sent him my GitHub link, the repo. I was like, okay, yeah, you should clone it and do a PR, make it change, all of those. And he didn't tell me he didn't know what I meant. What he did was he found a way to download the repo as a zip file, which is not bad. He opened the zip file, he made his modification, he zipped it back, and he emailed it to me. And in that moment, I didn't know what to say. Right, I didn't know what to say. And this is an international project. This guy is from Egypt. Well, I had to be polite and I had to unzip it, look at the changes he made, and like kind of update my own side. So okay, that's a lot of laughter. Okay, I think there are people that really understand GitHub and why that is so funny. Yeah, it was so funny. So these are this is here for those that do not know Git, because when you know Git, you are going to look back at this and you are going to relate to it. But for those that know Git, we are starting our journey. Git initialization, you track our progress, Git add, we commit first step into robotics greatness. I believe that's why we're here in the first place. Push yourself to the world, Git push origin main. I'm not going to explain on any of this now. If you don't know it, when you do, after the end of week 1, week 2, you are going to come back to this and relate. Now, we have never forget growth is version control. And I will show you growth. I will show you growth is version control. There is a topic we are going to cover in, I think, week 6, week 7. And when I was preparing that topic, I had this muscle memory. I realized that I think I've seen this somewhere. And I went back to start digging my LinkedIn. Apparently, 10 months ago, I took a course on it. And when I looked at that post I made on LinkedIn, I realized I didn't really understand what I was doing that particular, like 10 months ago. But now that I am actually making notes for the course, I know well enough to make notes. But the first time I saw that in 10 months ago, I didn't know how to do it. So if you do not document your progress, you would not know, oh, this is how much I have grown, or this is how much I have actually, like, growth is version control, really. You go back in time and then you see that, okay, this is what you've done. It must not be on LinkedIn, but I actually urge you, whatever there's this saying. I don't know where I saw that saying. I don't know. I read a lot of things and don't know where it is. So, but it said, what did it say? Ah, yes. If you did it, post it. And that was like a way of like branding yourself. It's a way of saying, okay, I have done this, put it out there so people can see it. When we talk about jobs, on the week where we look at how to get jobs and how to get all these things, you would find out that putting yourself out there is very important. It's extremely important. But let's leave that talk for when we get to talk about that. Now, what languages? This is something that I feel should not bother people. What languages will we use? Python, C++, Rust, MATLAB. This is Python. Sorry. This is Python. This is C++. This is Rust. This is MATLAB. And it was in the form you all filled. From the statistics collected, most people knows Python. Almost everybody have a thing or two to do with Python. C++ was the, not that much, but okay. Rust, nobody has any idea, except some few people who have done like 2-3%. And as for MATLAB, I understand why the usage is low, because if you are using MATLAB in Nigeria, you are most likely using cracked, and that is a bit difficult to get. That's a bit difficult to I mean, they released the new version of MATLAB, and get into PCs a bit. So only there are software that only people that had it before still have it. I understand that. Now, what language will we use? For convenience, we'll use Python, and I made that decision day before yesterday. I made the decision day before yesterday because almost everybody, 90-something% people, it's Python you guys are familiar with. But again, I would urge you to learn C++. As a matter of fact, I would intentionally give tax in C++. I mean, you could use Python and C++. In fact, there's a project I'm working on that uses C++ as the engine, as the main calculation, and Python as the interface. What I mean by that is, we all know C++ is faster, and if you do not know C++ is faster, you have a long way to go, but still you would catch up. C++ is faster, and then Python is slower, and there's a reason why C++ is faster. Okay, C is faster than C++, but C does not have object-oriented programming. And now I'm becoming a little bit too technical, but let's keep it simple. Think of it like this. Python is built on C++, and Python is an interpreted language. So think of it this way. When you run a Python code, it has to be interpreted first before it's even executed. But like C++ is being compiled like straight up into machine language. If it's still a bit too technical, would simplify everything. MATLAB, is MATLAB faster than Python? What was the theory then? MATLAB is faster than Python. MATLAB is faster than Python because of the way it uses C++. There's an engine it uses. And then Rust. The advantage of using Rust is Rust is slightly faster, but there's a way it handles garbage collection. But again, that's a little bit too complicated. So as we go on, long story short, we're using Python. But from time to time, I would impose C++. So what's going to happen is, for those of you that do not know C++, you are going to be learning C++ on these free days, at a pace. Your final project, your capstone project, will be done in whatever language you're convenient with. But consider it a favor that I'm imposing C++ on you, because the world runs on C++ actually. Now, what topics are we going to cover? There are lots of theories we are going to cover actually, and I put everything in this repo. We are going to okay, we have time to swing over to the repo, and let's see what we have there. Okay, so I reckon my screen is a bit small, so let's do this. All right, so some people must have seen this repo. On this repo, we are everybody's going to have access to this. It's literally a URL. I'll post it in the chat in case Okay, hold on, this is this. First of all, that's the link to the repo. Okay, there are some questions here. Okay, to port a simulation from ROS1 to ROS2, what do I mean? Okay, please let's prioritize C++ as well. I mean, I'm going to impose it, and at some point in time, yes. So when I mean to port, okay, let's do like this. Think of ROS1 as a way to I'm trying to simplify it because think of it as, when I say stack, ROS means robot operating system. And no, it's not an operating system. I know there's operating system in it, but I don't know why it was named that way though. It's not an operating system. It's more like a stack. When they say stack is like a couple of technologies. So ROS1 is the first ROS. What ROS do is, on your robots, let's do like this. On your robots, you might probably have a camera. Yeah. And let's say you want a robot that can move. Let's maintain to move from point A to B. What do you need? You need a camera. You need to see, or a LiDAR. But for simplicity, a camera, because some people might not know what a LiDAR is. You need a LiDAR. You also need tires, wheels. So you have the LiDAR, you have the wheels. What do we need? Basically, that's all we need. We don't need a okay, let's assume that's all we need. And then we need something that would let the robot think, because just like your phone, just like your laptop, there's a CPU, there's a processor. So then there's a processor. What ROS1 normally do is, ROS1 would control the communication between your camera and your tires and your processor. ROS1 runs on your processor, basically, and it just controls different components of your robots, right? Good. So you can say, some people might say it's a communication protocol. No, that's an incorrect definition, but get the idea. The idea is to get concept. Now, ROS2 does the same thing, but it does it in a different way. We'll get into that detail. But when I say to port from ROS1 to ROS2, ROS1 have a very major problem, and ROS2 fixes that problem. What's the problem with ROS1? The camera is hardware, but when I say, you might think, okay, how does ROS connect your camera to your tire? Now, what it does, it gives like a software version of it. Let's put it like that. So your camera has a node. It's called a node. Your tire has a node. 4 nodes, actually, depending on how many drivers. It could be 2 tires, but you get the idea. So what happens is, ROS1 uses one channel or one master node to communicate to all of them. It might sound reasonable. After all, you have one brain to communicate to all the components. But when you have like very big systems, having one master node is a point of failure. Meaning, if that node goes kaboom, you basically lose everything. That's a simple way to put it. So ROS2 kind of solves that problem with a distributed network, DDS. Yeah, something like that. So what happens is, simply put, we had a simulation, which is a robot that is not hardware, that is not like physical. The robot is in the computer. You can build a robot in computer from start to finish. I can show you a few ones, but let's stick to the idea. So we had this underwater simulator. It is used to simulate underwater robots, but it was running with ROS1. So we had to find a way to convert it to ROS2. I hope you understand now. That's just the idea. So it's called porting because we do not rewrite the whole thing. We simply just say, okay, this node was communicated to master node. So we're removing the master node, we're replacing it with probably a couple of channels. So, you just like rearrange things and rearrange it in a very complex way. That is the idea um behind porting from ROS 1 to ROS 2. Okay, so where was I? I dropped the link to the it's still going to be on the WhatsApp group eventually. So let's go back to the things we are covering. So this is something some of you must have read. I'm affiliated with all these companies somehow. These are the things we would get from the training. Of course, there's no need to read it. I must have said everything already. The prerequisite is just a laptop. Yes, we're going to install the softwares ourselves. Most people are using Windows. Some people are using Mac. But we'll get it done. So we are going to have the first week. This is like the installation. We'll look for a way to get the main softwares we need Python. We need C++, but Linux comes with C++, so my brain naturally did not include it here, but we're going to also get that done. VS Code for those that do not have it already, and then we would have to find a way to get RVITs and ROS 2, because nobody uses, people still use ROS 1, but I mean, ROS 1 is no more supported, so ROS 2. And then Gazebo as the simulator. There are a lot of other simulators. We'll go back into that. Now we also look at Git. This picture shows everything we're going to learn in Git. Nobody is building a pipeline for this course, so we're not going as complex as all those things. We just need to know how to clone. Okay, my mouse, I can see my mouse. Okay, we need to know how to clone, how to commit, how to push, how to get a pull request, how to merge it, how to also fork a repo and things like that. Then we are going to look at the roadmap of robotics. Some people already know all of these, and but just for the sake of those that it's completely new to, so yeah, we'll do that. And then the first thing we look at, we also look at ROS, and then every other thing is here. There's some things that are interesting, AI in robotics. And then this is something people also requested for a lot. This is where we look at real world robotics. We look at the career paths, the masters and the PhD. Oh yeah, and Erasmus Mundus. I am an Erasmus Mundus scholar, so I get asked that a lot. So yeah, we'll cover that. Now, we'll also look at a couple of jobs that I have done. The first thing that comes to mind, this whole thing looks like a brain. It looks like you're connecting different nerves to different nerves. Yes, that's basically what it is. And the result is this stuff. Now, there's something I want to say about hardware and software. I would like to call it I don't know the word. It's not a fallacy. It's okay. Let's say it's misunderstood. It's misunderstood because yes, you need software and hardware to work, but I have been working. I have like a very rich portfolio, and most of the jobs are softwares. Reason being that robotics is very expensive, extremely expensive. This robot here, this particular one on this video, in real life, it's a now robot, and it costs around, I think, 4,000 to 8,000 euros, which is easily 10 million thereabouts. So what happens is, before you get a robot like this to do something, you want to be very, very, very sure that everything is right before purchasing a robot like this. So what happened was, this is the simulation of the robots. This particular job was for a Kuwaiti company. This robot was in their lab. Clearly, they could not ship the robot to me. So I had to do everything in simulation and then send them the code base they need, and they have to like flash it on the robot. And now the only thing we have to do is a popular problem called sim to real. Sim to real is when they look at it on the actual robots and then they compare it to simulation. If there's anything different, we just fine tune things like that. So today we're not talking about the details, but yeah, this is also something I played with in Greece. When we come to this, would cover it. So let's go back here. We're here now, and I've showed you a little insights on things we would cover. Now, what are the expectations? What do you expect from me? You expect clarity, so that's why I take time to break down some things. There is a saying that if you cannot explain it to a 6-year-old, you do not know it well enough. But I do not fully believe that, because there are some things that are inherently complicated. They are just supposed to be complicated. So you just like grow into it. One very distant example will be quantum mechanics or quantum mechanics, depending on how I want to pronounce it, where they said nobody understands it intuitively. And it's true, because in my final year, for some reasons, I was fascinated with quantum mechanics, and I really studied it. The only thing I understood was why they gave somebody a Nobel Prize, and that's because he confused everybody. So yeah. You expect guidance from me. Yeah, I'm supposed to share my journey, um, how I got my master's, how I got my PhD. Let me rephrase that. How I got my master's and how I got my PhD offers. Yeah, that's the best way. So I'm not doing a PhD yet. Support. I'm supposed to be on the group. You have questions, feel free. You have problems, go for it. No question is dumb. I'm sure you've heard that a lot of times. No question is dumb. It depends on the setting. I'm not going to lie to you. It depends on the setting, because I was on this. I had this gig with this US company, and we had this conference call. So we had the hardware team, everybody, hardware, software, and it's a full stuff. And I am the embedded system guy. For some reasons, they already had this robotic software guy, so I was embedded. And there's what is called an SSH, for maybe if only those that have actually worked with maybe network security, but think of it this way. How do you program a robot? How do you actually type the code and put it inside the robot? So there are different ways. You can maybe put a memory card and like copy the code, and then you put it on, like if it's a Raspberry Pi, we'll come to that. You just put it on the robot. Well, you know what a memory card is. That's a way to get it to the robot. But that's a very stressful back and forth. So we kind of open a terminal on the robots called an SSH, where we like upload to the robot. Long story short. So on the SSH, you need a password or a private key. Yeah. And I was explaining to them. I wasn't explaining, I was suggesting, instead of using a password, use a private key, so we can like store the private key on the robot, something like that. And I was embedded, meaning I was hardware guy, right, for that particular gig. And the robotic software engineer asked me, what do I mean by private key? And my face, like the look I gave, everybody laughed on the meeting. Like I really gave that look that, okay, that's a very dumb question. But this is not a work setting, so you are allowed to ask any question. I do not expect you to know everything. I do not expect you to know anything, basically, because if you knew it, you won't be here. So feel free, ask anything you want to ask. Now, opportunities. Yeah, you're supposed to get some opportunities by doing this. Yeah, there is this option for an internship with um Aurora, if you wish, but it's most likely going to be remote, and you're not getting paid. Actually, you might even pay for it. What do I now expect from you? I expect consistency, but I expect consistency. Yes, I expect consistency. I expect curiosity. It's a normal thing to just copy code. ChatGPT, do this for me. Copy, paste. I like that. You copy, paste, copy, paste, copy, paste. Once your code exceeds a number of lines, ChatGPT doesn't remember. ChatGPT uses like a linked list with like a couple of metrics, but like the architecture that it's built on, it is just normal for it to lose track of certain things, and you can't keep on coding with AI for the rest of your life. No, don't get me wrong. We use AI. I use AI, but at least understand the fundamentals. Know why your code does this, or know why your code does that. That's all I'm saying. I use AI. AI is not bad. I mean, AI is it's going to come and replace a lot of things, modify the way we do a lot of things. No contest, right? But if you do not know something and something breaks down, it's going to be a lot of problem. If you go on LinkedIn and search vibe code fixer, you're going to see a lot of jobs. There are like people that actually specialize in fixing vibe codes, because a lot of people are fucked up a lot of things coding with AI. So collaboration, I expect you guys to collaborate and not compete. Yeah, I mean, you could compete, but collaborate. That's the thing. Nobody is hiding. Nobody is covering work for another person, but nobody is copying too. I want a growth mindset. Be willing to fail. Wait. I think there's a slide where I explain this. But okay, I'll be willing to fail and be willing to learn. Rinse and repeat. Yes, this is the mindset. Good. So the text in green, those are very popular saying within the, let's say, the Aurora network. Curiosity over perfection. Do not be afraid to ask questions or experiment. I know there are some interns that work with me. Before they do something, or before they put a code in the terminal, they would ask, what's going to happen? Like just press enter. Provided you are not, provided you are not flashing your hard drive, almost anything you do can be reversed. Whatever you break can always be reversed. That's why I also emphasize Git control. I always Git and GitHub is compulsory, because it saved my life when I was doing Oversabi one time. I spoiled my whole project somehow. So I had to, because I used Git, I had to like go back in time and like restore the functional. You ought to know Git. So run into the unknown. Robotics is about exploring the unknown. There are three things. There are the known, there are the known unknown, and then there are the unknown unknowns. The known knowns are pretty much easy to solve. All equations are complete. The system is fully defined. Everything is good. You can go on. And then there are the known unknowns. The known unknowns are the things we know that we do not know. So we try to know them. And the unknown unknowns are the most scary things. These are the things we do not know that we do not know. And most times they just come at us and we have to learn. Now, fail fast, learn faster. Every error is feedback. This is a control, in control systems. This is something you come across. Every error is feedback. Debugging is not a setback. It's part of the process. Fall quick. Just fall quick. Now, consistency beats intensity. I know there are some people that one morning they are so pumped and they do everything in one day, and then the next day they don't. They don't do it for like 2 days and then they come back and it's like they're starting afresh. Like, be consistent. That's the idea, right? Good. Now, collaboration over competition. Help your peers. Like, help people, put people through. Like, show people Ray. And all of us got a day. That kind of thing. Like, we're all together in this thing. That's the way I see it. I don't see it as anybody outsmarting anybody or anybody. Now, we have a global vision. Yep, global vision, local pride. I'm a very indigenous person, highly indigenous. So I'm proud of my roots, regardless of how things tend to be when you're out of the country. And I mean, not to be political, but we are aware of somebody that's denounced the whole citizenship or something like that. So like I understand how it can be, but like your country is your country, it's your pride. So build it. So remember, we're all in this Nigerian robotics community, but we can compete worldwide. So carry waka. Carry waka is like just move anyhow, like move free. A lot of people that are on Aurora are applying for scholarships. Some are even I think Sakai will be traveling out very soon. Like a lot of things are going on, and I I encourage it. I really do. All right, this is the WhatsApp group where we are supposed to connect. This is the WhatsApp group. um okay, sudden realization that I cannot copy it from the slide right now, so let me do it like this. Just a minute. I want to get the WhatsApp group link. um, okay. All right. All right, that's the WhatsApp group. I think some people are already asking for it. Can we intern with you? Who is we? How many people are you speaking for? Can you just send the link here? Yeah, I've sent the link already. So feel free. Um, okay. Okay. In the story time. All right. So for those people that a little bit of story, I'm guessing everybody is. But if you are not interested, this is almost like the end of the line, almost the end of the presentation. So what am I trying to say? This picture is I had to like take it apart to get this picture. It's a project I worked on in April. The idea was we can see this kind of thing that looks like eyes. So it's an ultrasonic sensor. The idea of the robot was it is a telepresence robot, a robot that would display, you could communicate with it via video call, and it's like going to be following you around. How do I put this? Let's put it this way. I'm in Lagos, you are in Abuja. You have the robot in Abuja, right? Now you are going to call me via video call, and I would be in Lagos. I would receive your video call, and I would show up on the robot screen. And as you move around, the robot would follow you around. So for those of you that are in long distance relationship, consider. So it's like having the person's face, like you move around, you walk around. Yeah. So that was the idea. If you let me drop the name. let me drop the name for you. It is called a, it's not really like a someone says Star Wars. Yeah, it's called telepresence robots. I hope that's how it's spelled. I hope that's how presence. Okay, that's it. Telepresence. So good. So that's the idea. The robots was something like that. And to achieve this, let me just go to the official page, or like the documentation. Mm, okay, so we can see a new screen. This is, for those that are not really familiar, this is Upwork. So okay, I think this page has the better detail. So we had, if you can see this particular screen, this one, this is the app that that I built for it. We can see forward, backward, left, right, stop. These are like controls for the robots. So you in Abuja with the robots, you can control it with this particular web app, right? At the same time, you can like leave it, put it on auto, and it just follows you around because it has like a couple of sensors. Now, for those that are like very, very experienced with robotics, you would quickly realize that it might not be so efficient to follow you around because the LiDAR, or sorry, the ultrasonic sensor is only facing one direction, right? But there's like a motor underneath here that like rotates it round. So I mean, you can get like a range. I mean, it was pretty basic. So um this had a Raspberry Pi at the bottom. Let me come here. Share this instead. So this has a Raspberry Pi. This, when I said Raspberry Pi, this is what I mean. It's the brain of the project. It's the brain. Like, if we liken this to a human being, this is what does the thinking. And now this is the speaker. The speaker is down here because, so ideally, the robot has this tube, this long tube, where the screen is mounted at the top of this tube. So the screen is at human height. And then the speaker is supposed to be up there too. But like, we brought the speaker down so we can like just take these close-up shots. And this has an Arduino. For some people that have also worked with Arduino, or maybe done a little bit of embedded systems, and we know what an Arduino is. An Arduino is a microcontroller, and a Raspberry Pi is a microprocessor. We'll talk about those differences later. But we have this, we have the eyes, we have the brain, we have the legs, or the wheels. So the idea was to make everything like work together. But there was a catch, there was a twist. We were not supposed to use ROS for it, ROS or ROS1, because it makes it a bit easier. It was more like this little challenge that the company wanted. They wanted everything done from scratch. And I'll explain very soon. No, in coming lectures, not today. I'll explain why doing things from scratch is a bit more difficult than having ROS nodes do things for you. So this took about a week to put together and code. We had to manually write the drivers for the motor, the drivers for the ultrasonic sensor, the drivers for the tire and everything. And this basically is how robotics is. This is like an explanation. This is like one of the ways you can go into robotics. This is like the easiest way. I won't say easiest, I mean like the starting point, let's put it like that. One of the starting points. Anything above this, we have robotic arms, we have other things that are a bit more complicated and all of that. But this is something that is close to you. If you wish to replicate this exact project, it's not going to exceed 500,000. The Raspberry Pi is about 200,000. Arduino board at most is 14,000. Batteries, ultrasonic sensor, throw in probably 5K here, 10K there. And also the cost of maybe burning your boards, because some people do not read data sheets before they do things. So that's still for another day. I'm guessing there are questions. Okay. Hi, please. Have the softwares to install been shared yet? No, they have not been shared yet. I want to create a group. No, I've created a group already. You can see the link up here. Okay, so 2 classes per week. Could you please specify the days? I mean, I felt Tuesday and Thursday. That was mostly what was on the. I had this pretty timetable that I did. Yeah, I had this pretty timetable. Tuesday, Thursday. For some reason, I felt Monday should be okay, and then Thursday, and then Monday, and then Thursday, and then different things. So, I think I just stick with Tuesday and Thursday. Tuesday, Thursday, Tuesday, Thursday. We could do Monday, Friday, Monday, Friday. But I prefer evening. Almost everybody preferred evening because there's some people that go to work, some people that go to school, and da da da. But the day is it's flexible to me. It's very flexible to me. So I would say Monday and Friday. I can strictly say Monday and Friday, and then everybody adheres. And maybe if there's like sufficient number of people that it's not going to be convenient for, you let me know. That's why I'm creating a group in the first place. You all are VIPs. Okay. So please, where's the link for the group? Okay. Tuesday and Thursdays works. Yeah, Tuesday and Thursday works, so that's fine. Okay, so do we get, yes, you get certificates after. I've covered that before. You can also check on the websites for the training. I also pasted that too. We get certificates. A lot of questions that has been asked. I actually answered them. So yeah, I would love to show the code base for this particular project, so you people can maybe see. Let me just do that. It's not like you're going to learn on the spot though, but you get an idea, a more concrete idea of how things work. Right, so we can see a new screen. Right, I'm on GitHub, and what was the name of this project? Sorry, pounds. Okay, so this, okay, it's a bit tiny. All right, so we have something like this. This is how GitHub is for those that have not been on GitHub. It can look scary, but you just get used to things like this. So I told you, now code needs to run somewhere. Code does not just exist, like it's not just a floating idea. It has to run on a hardware. And here there are only 2 things that can run code: Raspberry Pi and Arduino, because they are the things that have processors and controllers. Think of them as they are the computers, they are the brains. So the code was like divided into Arduino code and Raspberry Pi. And then I have like a couple of scripts for streaming and for viewing the streams, because I said we are going to send like video call from Lagos to Abuja. So something starts the stream and then something views the stream. Just classic things. And then for Arduino, we have for the motion control, and I have like a test for the motion. For motion control, we have like a file for motion control. For the Raspberry Pi code, I had a couple of templates. I have motion controller. Now we are going to talk about control and controller. These are just things we'll come across. There's a requirements file. and a couple of other things. Yeah. So we'll go into those details later, but this basically is the code base or the stack that runs on the robots. By the end of this whole training, a lot of these things will make more sense. And for those people that use ROS, you probably might be able to see how messed up this code base is, because we have to write low level code for every single thing. Meanwhile, you can just use like ROS serial and a couple of nodes to get things done. All right, so we're gradually coming to the end of everything. Yes, now a little thing that I wanted to do, I wanted to be as honest as possible. When I mean as honest as possible is some people wonder, how is it like when you get a job in robotics? How are things like? Well, I don't I I'm somebody that I'm really satisfied with one job, not because I mean the job doesn't pay, but because I like doing a lot of things at the same time. It's just fun. So I took up like a whole lot of gigs, and for each of them, I decided to have like this session where I ask, how much do you think this kind of work is worth? Or how much do you think you can get doing something like this? So not only does it like ginger you or like keep your drive in check, you also like, okay, hold on. Okay, yeah. You also see reasons to persevere, like reasons to like push on, to continue. Because like at the end of the day, it's all going to pay at some point in time. So we're going to do a little interaction here. I've explained the idea of the project. I've explained we had to write things from scratch. I've explained how much a couple of things cost on this project. Basically, you have like the concept. You have the concept. You don't have the full maths yet, or at least you have the concept. You have a little bit of the maths. You know how things connect. We don't have the codes. I showed you the codes, but this is like the application. You basically have an overall background. Tell me, leave it in the comments, how much something like this, like to build something like this, how much will you be paid for it? How much will you charge for it? How much do you think the work is worth? Yeah, there'll be a Q&A section. There'll be a Q&A section. So there's no rough guess, no rough estimates. 750K. I think 100,000. Over 1M, probably 600K. Naira or euros, it's a matter of conversion. Drop whatever you want. As a matter of fact, it's not an European company, so it doesn't matter. I would convert it myself. 800K. Okay, someone said, someone just said lazy 5 million. Lazy 5 million. Okay. All right. Zozo Pearl. I hope that's how your name is pronounced. I'm sorry. The question is, you understand the whole idea. I have given you, I've explained. As a matter of fact, I've done more than explain the explanation that was given to me about the project. Because when they give you a project like this, it took me 1 week does not mean it's 1 week job to do. Like, how do I put this? How many hours can you work? Most people work for 8 hours straight or 5 hours straight. And if you work at 5 hours or 8 hours, it's probably going to take you 3 weeks or a month. Like, I work for like probably 17 hours straight. So it's different. It took me 1 week. It's a different story. Um, it took me 1 week, but it took me a couple of hours, a lot of hours. Okay. So where was I? Okay. Are you to buy the materials? No, the materials were shipped to me. The materials were shipped to me because you don't buy. My price go increase 17 hours. If the cost of the production is roughly 500k, then my profit should be 5 to 10% of the capital cost. That is a business mindset. But by the time the cost is 500k, and then your technical or because your software suffer. By the time you don't see 500k material, but your software is like 2 months, you won't be saying something like this. So this is like a business side of it. So 10% of 50k is, so 500k is 50,000. So you're telling me you charge 50,000 for that? That's no, that's not it. Okay. So I'll put it in the chat. I'll put it in the chat. And mind you, mind you, the the company that gives you the job matters a lot. The country they are in matters a lot. So this is something that it's a secret I'm going to let you guys know. The charge you give, a Nigerian client will be different from that of the US, different from that of UK, da da da. So somewhere first said 1 million, and somehow he has gone to arrange. From every indication, like from the prices, I can estimate who knows what and how. Queen, you can't charge per hour. There's a reason why they don't charge freelancers or software guys per hour, because how do I put this? Um, the guy giving you the contract, what be this one with us 7 million, be thief. The guy giving you the contract, um, he knows that you might face a problem that might take you 11 hours to debug. It is not his fault that you missed a semicolon in one line of code and you don't know that you missed a semicolon, because you can miss a semicolon in C++ and end up debugging for 11 hours. That's not his business. That is your technical drawback. So he does not have to pay for that. So as I give on a technical idea, we'll still balance it with business and the way things are in real life. So this is how much that was paid. That semicolon issue, you see semicolon, that's how much the work was, that's how much was charged for that. And I'll be honest with you. You can probably do the conversion as fast as you can. I'll be honest with you. That's the only reason why I was retained was because I did it in 1 week. Yeah. But people here, oh, you did it in 1 week, and it's like, okay, it's easy. So I don't rush to convert them. People here, you did it in 1 week, so it's easy. And I'm like, okay, all right, it's fine, no problem. But the thing is, it's a lot of effort that you're going to have to put into something like that. And see, the game is rigged, in the sense that if you show how good you are for something, you don't have to apply for jobs. I'm literally not, I'm not kidding you. You don't have to apply for jobs, because, but then this is like the height of it. It's not everybody that don't get to apply for jobs, but like for those that are in, for those that have interned with me, for those that are like in the circle, they're like, and every time they get interview or they get a job, like literally it just comes, because they know, okay, yeah, this guy is substance, this guy is this guy. But how did they know? I think for the Christians here, they say you don't light a lantern and put it in the cupboard. Did you? Like, how do people know you are good? A lot of people that are on the training already know me before. Like, just because they even know me, they gave me 50k. 50k is a lot of money as per the way country day. So like, you have to like put yourself out there, something like that. I think there's something I wanted to show. Okay, that's pretty much it. So Yes, I wanted to say something. It's not all about knowing the tech. I went to Netherlands and things went up. We're at 1 hour 30 minutes already, so I'll just wrap up after this. Probably everybody have other things they want to do. So I went to Netherlands. I went to Netherlands immediately after I won a robotics competition in Greece. Right. So for the summer, I was just doing. For those that followed me on LinkedIn, I was just doing competitions after competition after competition. I was just basically just going in and in and in. So um in Greece, I won, and then 2 days later I was in Netherlands, and I was like so pumped and like so happy, and in that kind of thing. And I go to Netherlands and I lost. Losing half grade. There's that kind of losing where you you take you take like fifth, you take like sixth, seventh. And then there's the losing where you're not able to even submit the assignment or the task. That's the grade of losing. That and I sat down and I was like, But then in Netherlands, still in Netherlands, there were people that recognized me. They're like, oh, hey, Bakel, how are you? Like, Bakel, I just came home, but then they know me from LinkedIn. They know this, they know this, they know that. Yeah, life comes at you so fast. One minute, the European Institute of Technology is awarding you, telling you they are going to sponsor you the next year. The next minute you're in Netherlands thinking if truly you know anything about programming. But I mean, the detail I'm leaving out is I am a master's student and the competition was a postdoc competition. The competition was not meant for masters, it was not meant for PhD, it was meant for postdoc. So I was the only master's student there. And I was accepted. Why I was accepted is what I don't know. But I was accepted either ways. So I mean, some credits. I lost, but come on. So what am I trying to say? What I'm trying to say is I got contact of one guy, so good. He finished his PhD, very smart guy. But this guy has okay, the hand went down. Okay, so this guy finished his PhD, very smart guy, clearly better than me. And he was like, he didn't have a job, so he had to like take up this cooking doing this waiter job, serving at a restaurant to make a living. And I was like, you are clearly good. Like, why? And there is me busy packing in millions after millions every week, doing gigs for different countries. And then I asked him, let me see your CV, because I was genuinely curious. I wanted to help this guy. So he sent his CV. His CV was poor. I said, okay, your GitHub. There was nothing on his GitHub, like completely blank. I was like, okay, your LinkedIn account, nothing, like nada on his LinkedIn. He didn't even have an account. And that is, I mean, we've passed the era of our fathers used to tell us they will put their CV in their briefcase or in envelope and be moving from company to company to submit CV here, submit CV there. We've passed that era. We all know we've passed that era. So you have to like put yourself outside. And I looked at this guy and I was like, you are very good, but you decided to like close yourself out of the whole system, and it doesn't work like that. Nobody nobody rewards things like that. If you look at Nicholas Tesla, you will see how it ended for him and all of that. You just nah, it doesn't work that way. So at the end of the day, we all want to make a living. So you should try as much as possible to like put yourself out there. There's a whole different series on branding, so let's not go into that. Right, back to where we left. Okay, we've done this. Oh, this is where I say thank you for listening, and then we go into um question and answer session. So if there is any question and answer, feel free to unmute your mic, drop it in the chat box, and I would I will also answer. Okay, so I can make it looks like a lot to unpack. Here's the truth. You're not supposed to learn it all at once. How is working like 17 hours like? See that question there? That question is it's how do I say this? It's just it's just the way we see life. It's a limitation. This is why I say this. We are they paint us this picture that 9 to 5 is your mind still day 3.9 not already. Um we what was I saying? Yeah. They paint this picture that 9 to 5 is very stressful, or 9 to 5, the regular 9 to 5 job is very stressful. So, but the truth is, there are people that the very successful people actually work more than that. Hard work is relative. That's all I can say. I listened to this interview by Dangote, and he was explaining how he's um he was explaining his work ethics. And then there were people that were also saying you can just browse Dangote's work ethics, and there are some people that just do it. They just put in that number of hours. I don't advise anybody to work that long. Nah, I don't. I don't advise anybody to work that long. But it's a matter of what do you want? What do you what do you sing? What you do you find it? Are you passionate? Are you this? Are you that? Something like that. The if I might even draw this comparison or this comparison, we have Elon Musk on one side, who literally has to take I think he takes opioids, but he has this drug he almost abused. In fact, that's abuse in order to keep up. Now, I'm not saying go to that extreme, right? I'm saying we do not understand how much it takes to be successful at times, right? We underestimate the amount of work we have to do to be successful. And that's why when I see certain people doing things haphazardly, they one day they are serious, next day they are not. And in my mind, I'm like, this is not how you make it actually. This is not how you do that kind of thing. So another example I want to give is a couple of people here reached out and they're like, okay, they applied, they want to apply, for scholarship. And the first question I usually ask is, how long have you been preparing for this scholarship? And someone was like, oh, he has been preparing for 1 month, he has been preparing for 2 months. Now, in my mind, I'm like, if they don't give you, you are going to be pissed. Whereas there is me that prepared for like 11 months for a scholarship. Like I knew beforehand I was going to apply for that. So like for 11 straight months, I had to put in the efforts, right? But most people that actually get these scholarships, they don't spend a lot of time to really say the amount of work that it takes. Like, to be very genuine, the amount of work. People are like, they make it look so easy, like, okay, I did it. You nearly ran mad doing it. But yeah. Somebody asked also, are we going to be taught navigation? I did not see it in the scholarship. By navigation, I mean you're talking about autonomous navigation. Autonomous navigation is under Ross. It's going to be it's going to be calm if I don't teach navigation, because I know in my videos in some of the videos I sent out, I talked about navigation. Monte Carlo. This is similar to autonomous navigation, but yes, we are going to do. Simple answer, yes. We are going to do it. Localization problem. All right, so that's basically it from me, and I hope we all enjoy the next 8 weeks, and try as much as possible to maximize every single chance you have. So I hope everybody has joined the WhatsApp group. There are some people that were not able to join the meeting, so an email will be sent again to everybody with the WhatsApp group. If you've joined, you can ignore. I'm just giving that warning. So thank you very much, and I'm on the group. Feel free to reach out to me, and be nice on the group. Goodbye, everyone.